Hi and welcome to TRX Bench. Here today on the bench we have a Alinco DR-570 and this radio is not receiving on 2 meter, so 70 centimeter seems to be okay, but let's really double check what's going on here. So I've already connected it to the tester, and the generator is sending into the radio already, and we really should see here a full S meter, but there is really nothing. So let's really check what we have here. Okay, and we see that we are here testing already, as I told you, on 2 meter. And yeah, we are here at our 12 dB point. So our synod here is bouncing back and forth a little bit. That's because we are in the noise. But you hear in the background the signal, and yeah, maybe I can increase it here just a little bit. But you see, we are peaking here the 12 dB point, so that means that is definitely what we are testing for. And you see, we are really putting in whole a lot, so minus 53 dBm, and you might know on ultra shortwave radios we should see S9 at minus 93, right? And we are as high as minus 53, which is much higher, and we are still in the noise, and yeah, just peaking our 12 dB point synod, as you can see it down here. So that really means our radio is completely deaf. Looking here onto our receiver specs, we see that our 12 dB point synod should be at minus 16 dB microvolt. So Alinco is giving these figures in dB microvolt, so we need to convert it to dBm, or maybe whatever you are more familiar to microvolt. Alright, so let's see what really minus 16 dB microvolt means. Yeah, and looking here onto this table, we see that minus 16 dB microvolt means minus 123 dBm, and that is much more familiar for the most of us, I believe, and that again is equal to 0.16 microvolt. And we have seen that we are peaking the 12 dB point with minus 53 dBm. Yeah, and that simply means that we are really missing 70 dB. So yeah, the radio is totally deaf and is definitely not able to receive nearly nothing, right? So let's check our 70 centimeter band to see if that band is working as it should. Alright? Alright, but before I dial in the new frequency, let me drop here my level, the generator level, to minus 93 dBm, because with minus 53 dBm I'm really blowing out the hell out the radio. So Alright, minus 93, which is an S9 level, and let me go over to our frequency dial, and radio is set to 430, what is it, 100 megahertz. And let's see what we have here. I do not see nothing so far, but now, alright, so here we are. Here is our tone. I switch it off, and you see here we peaking 40 dB synod with minus 93, which is really nice. So let's have a look here on our S meter on the radio. And yeah, you can see it here. So it is S9 and peaking S9 plus, as you can see. So that means our S meter is obviously good and precise aligned, so no problem. And I can bring it over to the main receiver, and yeah, here it is, and it is still exactly the same. So you hear on 70 centimeter it is working just fine. So we definitely have a problem on 2 meter, where we really have no receive. Additional to that is, we see here, so there seems to be a light bulb defective as well, but that is not our main issue so far. Okay, so before we go ahead, let's test our transmitter. So first on 430-100, so in 70 centimeter. So let's see. So that is low, and yeah, so it is working 3.4 watt. And I also see that the radio has deviation, so that means audio seems to work as well. Okay, let me use the high position. So this radio only have high and low, so let's see what we get out of high. 23 watt. So okay, so that is fine. Now let me switch the radio to 2 meter, right, and let's test the transmitter over there. And alright, so we have 4.8 watt, which is fine on low, no problem. Yeah, deviation is given as well, but it would make me wonder if not, but anyways. So let's go to high, and let's see what we have. And we have, ooh, what is that? On high. Alright, so we do not get output power on high. That is interesting. But again, we get output power on low, but for any reason, once again, no. That is funny. So on high we do not get any output power. So that is interesting. Again, let me check here on, yeah, no problem. On low, 5 watt, very nice, no problem. High, nothing. That's interesting. Okay, anyways, let's start with our receiver, and then let's check what's going on. So therefore let's crack open the radio and let's check for anything obvious, and then we will see how we can go ahead. Okay, and here we have our radio open, and this side here with mainboard and power board is VHF, and when we flip it over, so we have here main and power board for 70 centimeter. And yeah, when we look around here on our VHF power board, so we directly see here a burned out resistor. So that might be the reason for not having high power on VHF. So we have to check that. But yeah, additional to that, of course, we want to see if our signal is going through our duplexer and finally here through our power or amplifier board, as this is here our output out of our duplexer, which is this thing here. And so we should of course see here at this coax cable, we should of course see our incoming signal, and then it go through our power board and will enter the main board, I believe through this cable here. So we have here a little coax cable, and we will enter in here. So what we can check is if our signal is entirely coming through and will be available here at our input to the main board. And of course we have to follow, if necessary, through the main board as well. But additional to that, we have to investigate what's going on here with our resistor. Okay, so the situation here is a little bit weird, as we have here, well, a well-known module, power module in, so the M57-726. So that is a normal VHF power module. So, you know, I have a different drawing here on our schematic, and I doubt that the schematic I have is completely valid here for this version. Okay, so you see here our VHF power module or amplifier schematic, and what we see is that we have here our IC, so our power module, and you see that we have 5 pins connected, and what you see else is that we have here an FB, so-called FB wire, which is supplying here our module with voltage. And when we go here through our unit, I can enlarge it, and you see we have here a little power source unit, and we see here our FB, which is directly connected to our amplifier board. And finally, when we go over here once again, here is, no, you can't see it, let's see. So we have here our FB input, and you see it is straight going on to 0.4, which means we should see all the time our 13.8 volt, because that is simply our input voltage, at our module. But when we go down here to the board, you may see, let me see if I can do it a little bit better, maybe that way. So you easily can see that here our power module only has 4 pins. So here our middle pin is not connected. So I wonder if this is here the original one, or is it simply a different version. But additional to that, I have here, of course, our datasheet of the M57726, and what we can see is, I hope you can see it, that pin 2 is our first DC power supply, and point 3 or pin 3 is our second DC power supply, right? And when we go down to the board, if I go down here to pin 2, let me do so, we see that I have no voltage. I mean, that is not so critical, because as far I press here PTT, you see nothing. That is nice. Yeah, I should put ground here to the chassis to be able to read here any voltage. Again, without doing anything, we do not see a voltage, but then when I press here PTT, you see I see 9 volt, which is funny enough. And when I go and switch here to what is it, low, I believe, yeah, it must be low, and I test then again here this point, we see 5.8 volt power supply here at our power module, which is funny enough, because normally I should see, according our schematic, we should really see our 13.8 volt, what we don't. So, you know, I am really already wondering if this is, yeah, a more critical and serious fault. I mean, of course, we can repair it, so that is not the question, but I mean, it is always a question what should be invested in a radio of this age. So therefore, I mean, it looks like that we do not have the right schematic, I mean, at least for our power module. What we know is that we have here our burned resistor. So that is the second power line, which goes over this resistor to our module as well. So question here is, why is this resistor burned out? So is there a short in our module? If there is a short, then that would mean this module needs to get replaced. I mean, okay, all is handleable, so that is not the problem, so we can manage it for sure, but it is always a question of money, what the owner want to put into it. And additional to that, we still have our receive issue, that this radio is completely deaf. So next step, I want to make sure that our incoming generator signal is finally getting here to our main board. that the signal is passing through here our power amplifier board to our main board to be able to see where we are losing our signal. And if it is going through, then additional to this power issue, we have an issue here on the board. Again, that does not mean that we could not repair it, but it is a question of money. I mean, it is an old radio, and you know, there are TYT units on the market, quad band radios for, I don't know, $250, euro, whatever, and that is much cheaper than to fix this old radio. But anyways, let's check what's really going on here with our incoming signal, and when we know where we are losing our signal, or finally if it is passing through, then we can decide how we really go ahead. Okay, so what I gonna do right now is I want to probe here our incoming signal right here out of the duplexer, and we should see I've set here our generator to -70 dBm, and I should be able to read our -70 dBm here at the input to our amplifier board, or if you will, the output of our duplexer. And then I want to see if we can finally see here our signal down at the connector to the main board. So this both tests I want to do, and then we go ahead. Alright, so here we have our spectrum analyzer screen, and now I go down here to the output of the duplexer, or to the input of our amplifier board. So let me go down here, and yeah, so what we see is that we really have our -70 dBm with 145.525 megahertz. So that means the carrier without modulation is at the right level. That is fine. So now let me go over to the input to the main board, and that should be here. And yeah, okay, we lost 1 dB, but that is fine. And yeah, let me see if you can see it here. Okay, so that means we have our signal here, and the conclusion is we have a problem here on the mainboard for sure. So that means we have two different problems on the mainboard for receive, and here on the power amplifier board for transmit. So two faults in an old radio always means that we really need to think about if it makes sense to repair such an old radio. So therefore the best is to talk to the owner to decide how to proceed. Anyways, let us do one more additional test to have more where we can talk about with the owner. I mean, we have here this power source unit, and we have seen that this FB output of the power source unit should be directly connected to our amplifier board. And let us see physically the board, this power source unit, and let's check if we have our 13.8 volt out of this board. I mean, this is important to know, because then we can confirm that the drawing we have here is not one-to-one what we have here on the board, so maybe two different versions, as I already said. Yeah, so let's do that. Okay, so therefore I have to flip over here our radio. Let's see that you can see it. Okay, and our power board is really down here. You see that we can get it in a little bit better, but yeah, so that is what we have, and I don't know if we can see it, but down there, let's see. Yeah, it is hard to see. It is hard to see. Maybe that way. Oh, not really. But anyways, this brown wire here is the FB. So that is what I was able to read on the board. And I'm now interested. If I go down here to the FB solder point, exactly down there, yeah, and I already can see it. So down there we have our 13.7 volt, which is going to somewhere. I mean, according our schematic, it should directly go to the power amplifier, but as we have seen, it doesn't. Yeah, hard to say how to proceed. Shall we go and gather more informations, or should I stop here and talk first to the owner? Okay, so I lifted this board here up to get access here to our UHF module, and what you see here, this is our FB wire, and it is here going to the UHF module, and so the UHF module directly gets supplied with our 13.8 volt. So hope you can see it. And then we have here a bridge wire, and I believe it should go over here to our VHF module, but it does not. So therefore next step would be I need to take off here this board, or VHF board, to see what's going on here. But yeah, to be honest, that is far too much what we do for the moment in time, as we need to decide how to proceed. Okay, I stop here and I talk to the owner, and then I will come back, and then maybe we see that we go ahead with this radio, or simply we stop here because it is from an economical point of view, it does not make any sense to repair such an old radio. Okay. Alright, and okay, so we decided to go one step forward, just to be able to have a better idea what's really going on here. So to make a final decision, we will replace here our resistor, and let's see if this is doing the trick. If yes, maybe it makes really sense to go ahead. If not, then we have to assume that really something is wrong here with our power module, and that definitely means $70 or euro for a module and a radio of this age, so that does not make sense. Okay, so let me simply take out here our VHF power PCB, and let's see what will be happening after we have replaced here our burnt resistor. Okay, so I've lifted here our board, and yeah, when we go here closer, you see we have here our next burnt component. So that is C17. So that is, yeah, it is definitely completely burned, our C16. And yeah, let's have a look where we find it here on our schematic to understand how it hangs together. And again, here is our final VHF final board, which we lifted a couple of seconds ago, and we have here our R11. So that is a resistor which burned out, and our C17 is right beneath. So let me enlarge it that we can better see it. Okay, so here we have it. So here is our R11, and this is our C17. So that is obvious, 1 nanofarad resistor, and yeah, the R11 is burned, so maybe that the C17 shorted out, and that means it is then simply a short to ground, which would finally burn the R11 as well. And yeah, to see it once again, so that is our transmit voltage. So always when we press our PTT, we have here our switching voltage. So that is 8 volt transmit VHF, and you see that is here the pass over our L6 and L5 to pin 5, but we know we have a different final in our circuit, and that is finally where we have to put our second DC voltage. So this drawing is wrong, or as we already discussed, it is a different, older, newer, whatever version. Right, so that means we have to replace both our resistor R11, our 150 ohm resistor, and of course here our burned C17. And if we are really lucky, we can have a little bit hope here that it really was only this SMD capacitor which simply shorted out to what reason ever, and that this shorted C finally killed our resistor, and that our final stage is still fine. So yeah, let's swap it out, and then we will get definitely a better idea what's going on here. Right, so we have here our new capacitor in, and of course we have our new resistor in. So it was a half watt required, and I put in here a watt. So I don't know if it is permanently getting a bit too hot, but that is then, if that is the case, and if that might have been a problem, this is definitely solved by the 1 watt version I put in. Okay, so let's put it together, and yeah, let's see if these both components are doing the trick. Okay, so all is back in so far. So let me connect here radio to the power supply, and you see that obviously was successful, so no problem. Let me see. Yeah, static is there, but we wanna check out if we get here any output power, and therefore, yeah, I have switched here the radio again to low power, and that is what we had before as well. And let me go here a little bit closer, and let's see if something happening now. Okay, so we have still our 5 watt, so that is what we had before as well. So let me reposition the camera that you can see our tester, right? Okay, so that is much better. Okay, so let's check here again our 5 watt, and you see 5 watt is given, and obviously modulation is also present, so that seems to be fine, and 4.7 watt, so no problem whatsoever. But now the minute of truth. So let's switch to high position, and yeah, let's see what we have now. And wow! So really our radio is back. It is definitely back, 38 watt, which is definitely fine. As far as I remember, radio is rated on VHF with 40 watt output power, and that means yes, it is definitely back. So now, of course, we have to look after our receive problem. But first, once again, here a closer look to the board, and of course you see here our new resistor. And by the look at it, it seems really so that the little capacitor shorted out, and the shorted out capacitor took finally the resistor as well, and that was the reason why everything was definitely down here. So that of course is a success. And okay, let's go ahead. Such an old radio, unbelievable. Okay, let's look after our receive problem. Okay, so I've taken the VHF mainboard here out of the circuit. Unfortunately, I cannot connect here, you know, all the connectors to the board and then bring it into a position that I will be able to do here some tests, and yeah, we are running out of budget here with this radio. So that is a little bit a shame, but it is definitely an issue, right? Well, what I have seen so far, so I was hoping that maybe there is also a burned part, but no, it is not. But what I found is that for any reason here is a modification on the board, and you see here that we have here a package soldered over here the normal components. Okay, so that looks to me like a modification, and we see here the Q1 with is a little front end dual gate FET, and then this kind of modification. So now I really would need to solder to all these points some extra wires to take measurements, but as I said, we are really running out of budget, and now it is getting more and more funny. So the only thing I have recognized, but I'm not sure if it is good or not, because according to our schematics there is a coil somewhere, so that we have here at this component, you can hear it, so there is really a short in all directions, and that is definitely a little bit odd. But as I said, there is a coil connected here to these points, so I'm really not entirely sure if you know, this is normal, that this component shows behavior as a short. So the last I could do is to take this component off and see how the board or the circuit then reacts. But yeah, let me show you the schematic that you know what I'm talking about. Yeah, again we have here of course our VHF main schematic diagram, and let me zoom in here a little bit. So here this point we have tested with this point here, where we tested with our -70 dBm to find out if the signal is coming over our amplifier board, and we found that the signal is fine at this point. Then of course we have here some diodes, and I was able to check these diodes, and it looks like that these diodes are fine, so no problem. Okay, and then we have here our front end transistor, and now for, I would say, a modification, we have soldered here, somehow we have soldered here a dual diode pack over it. So as I said, it looks to me like a modification, but it is nothing mentioned in the schematic, and Alinco products are not so many on the market, so I do not have a reference to check against another unit, so that is definitely a bit of a shame. So what I can do, or yeah, let us have a look here onto the board plan I have. And what we can see here is, let me see. Okay, so what we can see here, this is our Q1. So that is a little dual gate FET, and we see here the diode packs which are in the front end circuitry. But here on the board, on this plan, we definitely do not see a dual pack diodes, so nothing. And when we go back here to reality, once again we see that we have here our little dual gate FET, and that is a double pack. So to me it looks a little bit, as I several times said, a modification. So and when I go with my beeper on this component, it shows short in all directions, but as I said, there is a filter coil. Maybe it is where are we? Maybe it is this one here, maybe. Anyways, one of this filter, maybe the one which is connected here, and therefore maybe it is simply fine. So one thing I can do additionally, I take it off and let's see what then the behavior of our circuit is. If it is fine, great. If not, we are definitely running out of budget. Okay, I have the little diode here on my test fixture, and yeah, when we test now here the little diode, what we can see is that one side of the diode, so one diode is open, so it is only one diode working, so, and that means one is definitely faulty. So I don't know if that is the reason why our radio will not receive, but it is a kind of odd that you still can see it here on the board, that we had here our dual pack in, so you still see where this dual pack was sitting, and yeah, once again it is a kind of odd, and I really don't know if one side of this dual pack is open, if that is the reason why the circuit doesn't work, considering that this must be a modification, a kind of modification, because otherwise it wouldn't sit here on hook here of this both components, and if they would have forgotten it when they planned here the PCB, well, then we would see it in the schematic, but we don't. So that must be something what has been later added to the radio. Alright, so PCB is back, and you hear static. The radio is connected to our tester, and you see we are feeding minus 70 dBm, and that clearly means it still does not receive. Even we found here our little diode over there, which is not working correctly. but you see, we would really need to go deeper, but as I said now several times, we have to cut here, so we cannot go ahead. So that's a bit of a shame, but it is sure that we need additional components, we need additional time, simply for preparing testing. You have seen I cannot easily flip here the board over, that I can test from underneath, so that all would mean I don't know, another hour or even a bit more, and that is now the point where we have to stop. I mean, we saw a little bit of fixing here our final stage. So final stage is working, so that might have been interesting as well. But now we still have our VHF receive issue. But yeah, sorry guys, I really have to stop here. I load it up because that is what sometimes happens as well. So yeah, so it is, that is live, and as I told you, radios like this, I mean, this is a twin band radio, and you know that we can get a quad band radio for 250-260 bucks or so from TYT, and therefore it does not make any sense to go ahead with this radio. Okay, hope it was still a bit interesting, and thanks for watching, and catch you next time. Bye.